Hey, what's up, you guys? In this video, we're going to solve valid anagram, which is an easy LeetCode question. And in this one, you're given two strings, S and T, and you're going to return true if they are anagrams of each other. And what that means is that they contain the exact same characters as each other. And the order can be whatever you'd like, as long as they contain the same characters. So for example, car race and race car are anagrams of each other. Or if you saw the thumbnail, Elvis and evils are anagrams of each other. Something that's not two strings that are not anagrams, for example, are jar and jam, because one has an M, one has an R. So I'm going to go into a little diagram of how we're going to solve this problem. We'll write the code and then we'll debug it just to make sure we understand how it works. So to get started, the algorithm we're going to be using is we're going to take two hash maps and basically compare the unique character counts. And if they are equal, that means that they're anagrams of each other. But for example, if you right off the bat, if they're not the same length, you know they're not anagrams of each other because the unique character counts are going to be off. In that example, jar and jam, you would have a frequency count of 1 for R and 1 for M. And when you go to verify after populating these frequency maps, these two hash maps after your first pass, you know that they're not going to be valid anagrams of each other. So let's get into coding that. So I'll hop over to my editor, trusty PyCharm here. So I said off the bat, if the length of S is not equal to the length of T, right? We're going to want to return false, right? And then after that, we want to populate our frequency maps. So frequency map for S, frequency map for T is equal to 2 Python dictionaries for key value pairs. And then for I and range from 0 to length of S. And it doesn't matter which string you use here because they're the same length and it'll be the same if you use one or the other. We're going to say frequency map S. We're going to populate it. So SI, so for this current character, is equal to frequency map S dot get get the value at that key, which is that character. And if it doesn't find anything, give us a 0 and add 1. So it would be 1, and then we would say same thing for the second frequency map. Get at t.i, the character at that index. If it doesn't exist, give us a 0. If it does exist, get us the value and add 1. And the final step is just verifying if they match. So for this one, we're going to say for char in frequency map.s, if we access that key and we check the count, so this, if it's not equal to frequency map t.get char, and you have to use this .get, otherwise it'd throw a key error if it doesn't exist in there. If it doesn't match, return false. And if it does, we get through every single character count, and there's no mismatches, we return true. So let's just double check if this works. We're going to chuck it into LeetCode over here. And let's submit it. Accepted, so that's good. Passed all the test cases. Now let's debug and talk about the time and space complexity of this. So I wrote these couple tests over here. We have one TC where it's passing and one TC where we expect it to be false. So I'll place a breakpoint at this if statement and let's run this in debug mode, right? All right, so we're in. So we have S is Elvis and T is evils, right? So immediately the lengths are equal, so we're good. And we go and we populate the frequency maps. We'll go through and let's just place the breakpoint here and go there. So you can see the two frequency maps are populated exactly pretty much like the diagram I showed at the beginning of the video. And now we're going to go through each one and we're going to verify. So we're going to just go through frequency map S and then check against frequency map T. And so we say, hey, all right, the first character in that frequency map is E. Does that count equal the count in my other frequency map? And E is equal to 1 in that one, and it's equal to 1 in this one, so you're good. And so on and so forth. So L, we check V, we check I, and S. And they're all count of 1, so we return true. That's chill. But then we get to where S is jar and T is jam. And now they're the same length, right? So we populate our frequency maps, and you can already see that the counts, R has a count of 1 and M has a count of 1. So let's go through and see how it returns false. So we're checking J, that has a count of 1, A has a count of 1, and then we go to check R, and R has a count of 1 in this map, and then when it goes to access this, it doesn't exist, so it gives us a 0, and 0 does not equal 1, right? So it returns false. And then we pass our test cases. And so the time complexity of this would be O of n, because we need to loop through the length of the string. And the space complexity would be O of n, because we need to have a frequency map the size of the string. But if you actually think about it, the alphabet only has 26 characters, like the English alphabet, if we lowercase everything, which it says the input is lowercase English letters. The maximum size of the keys is actually 26 keys, and then if they're unsigned ints, it's actually a fixed space complexity. So it technically be O of 1 because it doesn't scale with the size of the, it doesn't scale with the size of the, as the input scales. Like there's a cap on the size. And yeah, that's about it. There's another way you could solve this if you sorted the two strings and use 2 pointers and then iterate them and make sure that there's no mismatches. And that would be, O of n log n, time complexity, because it's the best you can get with sorting. And it depends on what algorithm you use for the space complexity, but you could do it with O of 1 space. But this one has the best time complexity, so that's why I showed it to you today. I hope you found that useful and hope to see you in the next video. All right, thanks. See ya.